you're going to have like a bazillion agents doing a bazillion things, and you haven't really defined the domain well, and none of them are working correctly.
That stuff getting defined fairly quickly in an organization allows you to develop more agents versus kind of letting everyone run buck wild.
I'm actually building agents that know how to play poker. It's a game that I love. I love understanding like how does the betting work and how does bluffing work. They don't want to even get to 80%. They want 185% of what's capable or possible.
So you're thinking of these traders trading billions of dollars and they're looking at an ocean theme or like a carnival theme. It's like, what are we doing? So let's say a client has decided to build an agent. We're good to go. How would you actually do it? Like what tools, language models, patterns, frameworks? There's a lot of buzzwords that kind of come around. So I'm going to start with something that's pretty basic. How do you actually start building an agent, and where does a human fit in?
LangGraph, Langsmith.
I knew he was going to go right there.
Episode over. That's a wrap.
No, that's a wrap.
No. I guess like there's two pretty deep questions. First is like, how do you start? I would start by understanding the human process. I think you've talked a lot about that in previous episodes, and you should like and subscribe and go look at those. After you start to really understand the human process, so what are people doing and what are you trying to automate, you'll look at that like kind of 80% gap. So I'm going to try and automate 80% of the work that the people are doing inside of this work process, and I'm going to leave 20% left, the hardest, decision points. And sometimes you don't really know, but the hardest decision points, and I'm going to leave those up for a human in the loop. And as you're building the agent, you'll start to feel those difficult points. Like this one's really hard, processing this text is really hard, drafting these responses is really hard, whatever it is. And then just leave those and keep, pick up, right after that step in your workflow. So yeah, start with human, define the process, start automating the steps in the process, and then, leave the human in the places that are hard and then come back to them. So you can kind of get that full workflow automated out is where I'd start. I'd pick a framework to do it, LangGraph and Langsmith, have good eval and build on top of those evals so you can iterate on your prompt and stuff like that.
Can you explain at a very high level what is exactly is an eval?
Yeah. What is an eval? An eval is a test for a large language model or plus a prompt. And then it can expand to be like a test for an agent. So when we were building a AI therapist, that I actually think we talked about this in season 1. So I pick a different example. So in this claims remediation thing, we want to, take a document, an invoice, take a, claim, look at those and get like a specific set of output. And so an eval, you have a predefined set of data, and then as you change your prompt, you make sure that the LLMs output essentially the same thing. So if you're familiar with traditional software, we would write tests like unit tests and integration tests. Evals are a form of test for a prompt, and there's a bunch of ways you can build an eval. Evals can be string matching. They can test like exact equality. They can use LLMs to judge a response. Yeah, there's a bunch of ways you can build an eval, but you have those evals there. So then when I change prompts, change models, change anything, I can make sure that my system still performs as expected.
Gotcha. So you're looking at basically the agent behavior.
Correct.
It has to be consistent.
Yeah, and evals can test a full system. So like there's not as good of testing patterns built out yet for these things, but in a traditional software system, you'll have like integration tests, test the, and smoke tests, test like the full outside in picture. And then you'll have unit tests, test an individual method. In LLM world, evals kind of are the whole thing. So you can eval like a specific node inside of your agent. You can eval the whole agent. So there's not like, how do I integration test my LLM or my agent and then unit test my agent? Use evals kind of for all of them.
Yeah. It's a big shift from what people are pretty much used to for proof of like work, essentially. One One thing that you did say, Austin, that I want to click on a little bit more is, understanding the domain and like where the human fits, the human process, right? So when you're experimenting, if you're starting new with agentic work, find something really well. Like even if it's silly. I love poker. I'm actually building agents that know how to play poker because like it's a game that I love. I love understanding like how does the betting work and how does bluffing work. I know that domain well enough to where I can really experiment. And then for me, the evaluation loop when I get it going is much easier for me to feel confident that it's correct, right? So maybe don't start by climbing Mount Everest, like build a smaller agent first. But as you grow in that capacity, you get more confident and then you realize exactly how important it is to have the domain context and to have the process down correctly.
Gotcha. That was actually going to be my next question. It's like, how do you
Boom.
start, how do you start evaluating, like, what is the MVP of an agent? Like you said, like Austin, to your point, you said, that you look at the 80% gap is can an agent do 80% of what a human can do? But then how do you identify that part? What is like the happy path that you can identify and kind of solve for it?
Sometimes it's easier for me to talk about what not to do, maybe because I'm a negative person sometimes. But I think the issue is like,
So I hear, Micah, you're a negative person.
I've been called that sometimes. Okay. I'm just kidding. No, I think it's easier to talk about when we talk about MVP. Sometimes it's better to talk about what it's not. And I think the thing that a lot of these projects of building agents or integrating with LLMs is that they eschew this idea of a minimum viable product. What they want, like to Austin's point, they don't want to even get to 80%. They want 185% of what's capable or possible. So I think you have to really manage your expectations and like be really ruthless and make it really small and composable as fast as possible, right? Like make it small, make it tight. Like, and this feels a lot more like traditional software. You're going to get really excited about what is possible of the realities, but that's going to be unobtainable.
It's so hard to define an MVP in general because like the viability is depending on the domain, depending on the customer. Like if I'm building a airline baggage scanning application, viability is that like it kind of can do all of the baggage scanning and tell me where the bag should go and have a handful of other features. And if I'm building a social media automation posting thing, it's it could be much smaller. So viability is broad. For agents, the goal is to automate human process. And so when I think of like minimum viable agent, a minimum viable agent has removed a human from some part of a process that traditional software could not have done before. So we built an agentic system for a government transparency startup, and traditional one of the things it does is it takes recordings of local government meetings. So think city council, zoning board, that kind of stuff. And we want to attribute what people are saying to a specific person. But since you have just like a single recording, it's actually really hard to do. And on a Zoom call, it's really easy to say Micah says this and Shahed says that. And like one camera focused on a room, it's really hard to know. So we're using the LLMs to decide who's speaking by using context clues inside the conversation. Hey, Maggie, what do you think about proposal number 73? Oh, Ben, that was a good point. And then the LLM can start to build confidence in who's speaking when. That automated a human process. Just speaker labeling automated a human process. And so we were able to have the agent kind of be a minimum viable agent there, and then we can expand it based on what the next automatable part is. So that's where I'd start. It's like, what is one single process? Smart rarely means complex. At Focused, we help clients build lean, high-impact agents that actually work. Ready to build? Go to focus.io.
Do you think it's easy to get into agent sprawl versus, I know you talked about kind of like defining things by not doing something. Do you think it's easy because agents are not really, the architectures so far as they exist are not completely well defined, it's easy for us to get into these situations where we have agent sprawl.
I mean, I don't think that's
What's agent sprawl?
I'm just reading off the questions here.
I think agent sprawl could be defined as what happens in every software project where engineers start to over-engineer things. I don't think this is like directly tied to agents. I think this is a human problem and our propensity to create work and to not have a well-defined domain. So you're going to have like a bazillion agents doing a bazillion things, right? And you haven't really defined the domain well, and none of them are working correctly, right? Because maybe you have the separation of concerns on what the agent's supposed to do, not well defined. Maybe you're doing a way too complex architecture for a really simple system because you want to figure out like what an agent swarm would be like, right? So it's easy for us to do. And I think that we have to go back to that ruthlessness. Austin and I both love the Unix philosophy of software. Do one thing, right? Do one thing and do it really well. And so if you have an MVP that's well defined and you know that that's what the success criteria of that would be, then you've already started on the right foot. If agent sprawl is like a side effect of not understanding the process, not understanding the domain, and probably ambitiously trying to apply patterns that you don't understand. And so now you've got
Agent sprawl is
a lot
like
of
too
stuff.
many agents inside of a.
I think it could be too many, but I also think it could be poorly defined boundaries for what the agent's doing. So in your example, right, we have like speaker detection.
Okay.
But if that thing is not really well defined and understood, it's not going to perform well at speaker detection if it's trying to do 6 other things.
I see.
And I think there's a lot of places where we get excited about what's possible and we start glomming on all these features. And now you have sprawl, like you have no well-defined sub process.
I see. I was thinking of agent sprawl being like, I guess I'm way off, but I was thinking it being like my enterprise is building agents and we have one built with LangChain and LangGraph. We have one built with Crew AI. We have one in TypeScript. We have one in Python. One integrates directly with OpenAI.
But isn't that like the same thing in a fundamental layer? Like, isn't that similar to all kinds of sprawl we get? I mean,
that's what I thought it was, like technical sprawl. So like, how do we?
But I think they coexist in a lot of ways.
I think having too many agents do too many things is one thing, and then having a whole bunch of technical decisions across all of your teams. Like I do think having reference architectures, understanding how to distribute tools, understanding what the core agent architectures should be, what open source technologies we're going to use, how do we instrument and observe these things, like that stuff getting defined fairly quickly in an organization allows you to develop more agents.
Yeah.
Versus, kind of letting everyone run buck wild. I wish I had my cowboy hat.
You should have brought the cowboy hat for this
Tomorrow.
I do think this is just like fundamental software engineering, and I think teams that are really effective have thought about this because they've experienced this with technology before. Like, how many places have you worked at where somebody wants to go explore a new framework and now we're running classic Rails with fast API and we have Next.js in the mix and we can't make a decision on any of that stuff. I think the advantage that you have right now, and we're going to probably say it all the time, is that LangGraph and LangChain and LangSmith are actually a really good fundamental abstraction that you can use across the board. And so there's really no need to go buck wild.
Creating like some common patterns and then creating the common tools that are shared works really well. And I think that prevents agent sprawl in both definitions. So having reference architectures, understanding how to integrate memory into an agent, understanding how to integrate, your RDS databases or Aurora into your agents, having those adapters pre-built and defined is super important. And then on the other side, by having those kind of like technical decisions pre-built and defined, you have agents that kind of follow specific patterns, so they do less, right? And then we haven't talked a ton about, but I think there's the other side of that, which is like in the continuous delivery and continuous integration pipeline, having those evals established and part of your delivery process is super important. So if I make a prompt change, even a minor one, like changing spacing or, reordering sentences, the consequences of that prompt change can actually be fairly dramatic. And so having evals that are there to catch that is super important, and having those be like an automatic gate, my evals passed or my evals failed, is really important.
Want more hot takes and real talk on building with AI? Subscribe to /deploy on YouTube. Hit the bell so you can catch the next episode, especially if you're about to ship another agent.
It helps to have examples of these agents to really understand what they could actually look like. So I want to throw out some use cases for agents and talk through architectures that could make sense. So the first one I want to talk about, and it's kind of a cliche, everyone wants to build it, is a travel booking assistant. Micah, I'd love to hear your take on it.
Just don't do it. Like, don't build it. There's so many of these have been built. No, I'm sorry. It is the classic one. It's almost like a cliche. I don't know. There's a lot of different architectural patterns you could use for this. Probably the most complex is one that I alluded to before, which is like that agent swarm.
Mm-hmm.
I could see that being pretty beneficial, but hard to do correctly. They're very complex. What you have is like a group of agents that are all doing different work. So if it's a travel agent bot or something, I'm going to Japan next month. Book my travel. You could have like a collection of agents that are pulling data from different sources. Maybe one's pulling the best airfare rates from different providers. Mm-hmm. Maybe the other one is looking up tourist traps or places that you want to go to or avoid. The other one's trying to plan like your rail pass, because you're going to want to use the rail for that kind of stuff. And then at some point, this data has to be coalesced and come back to the user, right? So if it's poorly designed, you're going to be overwhelmed, or it's going to be a bad experience, right? So Austin, you might disagree with me, but I think a supervisor pattern would probably be a little bit better for that. But
yeah, these architectures, they can have one or many,
right?
I think this, so like fundamentally a swarm architecture allows agents to talk to each other at their own whim. So if I have 3 agents, A can talk to B and C, B can talk to A and C, C can talk to A and B. In a more defined or deterministic graph or a supervisor, you might have an agent, one agent that's communicating directly. So A can talk to A and B, but B cannot talk to C, and C cannot talk to B. Wow, that was hella confusing for a podcast. They'll put some graphics on the screen.
It's going to be all the numbers like floating over your face. Yeah.
Yeah. It's explained right here. Figuring out kind of where that interface makes sense or how the user gets talked to is also super important. But like, I would think in a travel booking agent, a swarm actually makes a ton of sense, so that like as the agents are all planning in their one domain, so like you have like you said, airfare agent, rail agent, activities agent, they're communicating, oh, they really want to visit this place and you're flying in too late to figure that out, kind of thing.
Yeah.
But then I'd probably go swarm with a supervisor. There's a lot of context getting fed up into a supervisor and then needs to get passed back down. And because LLMs are non-deterministic, even if you like temperature zero them, the issue is there's like a information degradation as I pass info back up to a supervisor, and then I pass that supervisor then decides what to do with it next. It can hallucinate. Mm-hmm. So travel or airline booking agent says to the supervisor, I want to book or here's, good flights for you on Tuesday the 19th at, 2 p.m. Supervisor gets that information and it, hallucinates. And now it's, Wednesday the 20th at 2 p.m. And then everything else gets planned off of that. So you have to really kind of manage that context too.
Yeah.
So I'd probably swarm over it. And then if you want to provide consistent voice, you take that, you'd swarm the planning, and then you take the plan, and then you have some sort of consistent, like humanizing, node that is the output node that takes a plan. This should all be structured data too, rather than like raw text.
There's some really cool demos of kind of UIs that are being built on the fly that in response to some of these things. So you have like a swarm and agent that kind of goes off and builds all the information. For example, you don't have to go to Airbnb and kind of pull up all the listings, because there's other things related to your travel. Like you have your flight, you have your train, you have your hotels. Like all of these things are kind of custom built interfaces for you.
Yeah,
Super cool.
I think like just-in-time user interfaces would be.
That's
I haven't
wild.
seen a really good example of it yet, but I do think there is some future in which like you're getting an interface that's kind of written for you as you're working.
Totally.
There's definitely demos, but they're very basic.
Yep. But
It's also funny to me that you're not screaming like running out of the studio right now, because like a on-the-fly user interface seems like pure anarchy from like a design perspective.
actually, no, I'm all for it.
That's cool.
Like, I'm all for it,
Yeah.
because I mean, it's, if you think of traditional, like the way design interfaces have been built, they're built for the majority of use cases, right? It's like
Yeah.
the happy path. Like no matter who you are, you have to conform to a specific user interface. What if you flip that and you allow users to kind of build their own interfaces, right? I mean, there's an extreme example of it too. Like we had, I used to build this futures trading app where one of the PMs wanted, or one of the stakeholders wanted, custom themes. So this is a futures trading app, and they wanted an ocean theme, or
That's amazing.
so you're thinking of these traders trading billions of dollars, and they're looking at an ocean theme or like a carnival theme. It's like, what are we doing?
That's amazing.
Right.
Yeah.
So it's one of those things, but it still gives the user kind of more control, and it allows them to understand their world better, right? I mean, that, I feel like that's more powerful.
I mean, I think the race to the bottom is catering to the median. So I'm all for it. If, like,
Wouldn't that be the race to the middle?
no, it's to the bottom because it makes nobody happy.
I see.
This is the definition of enshittification.
I see.
Like, and so like I think an interesting way to combat that would be exactly what you're saying, right? Like within a reasonable standard, these kind of reactive interfaces for specific users, and then like the personas themselves could actually have, a power user. You're not, maybe it's.
I thought we were doing pick the architecture.
Hey man, I'm going with the vibes, man. Go ahead.
That one where you're talking about just-in-time interfaces is cool too, actually.
It is cool. I mean, it's still an orchestra, but I want to get us back on track. But yes, another one a common one that we see is customer service. Like we talk about agents, like any human role that has agent in it, customer service agent or whatnot, that is ripe for automation, for introducing agents. So what are some architectures that we can see there?
Often for CS, it's a really clear workflow style agent. So because customer service is often very workflowy. So, do step A, do step B, take task from, queue, put it into new queue, that kind of stuff, with LLMs drafting or reasoning about responses at each point. So it's not a full, like, looping architecture or a swarm or even a supervisor necessarily. Where it kind of gets interesting is you often add tool calls. And so the tool calls, when I think about when you build an agent, whether it's a workflow or a swarm or a supervisor or something else, you have a bunch of nodes inside of a graph, and you're defining how each node can connect with each other. The nodes should be single responsibility. So a single node should be able to call a tool, or a single node should be able to pull a ticket from a queue, or a single node should be able to draft a response. And that allows better observability and iteration on each of those nodes. So for this one, I'd probably workflow.
Disagree?
I don't disagree. I do think it's cool that a lot of those abstractions so tool nodes are a really great abstraction in LangGraph.
Yeah.
So like it makes it pretty simple to reason about. But it would be hard for me to like argue a different architecture for that without just sounding dumb. So I'm not going to do that.
Nice. Good.
Fair take. Are there any architectures that you've seen that? So I'm going to flip it up a little bit. So instead of talking about use cases and what architectures apply, have you seen any interesting architectures that apply to very specific use cases?
So one I like. Do you want to go first?
Yeah, go for it.
One I like is like parallel tool calling or parallel node execution. So when you have that graph, you can map reduce, responses. So if I have a research agent, I can have it go research, any number of sources. So I'm like looking at Twitter, I'm looking at the internet, I'm looking at, internal documents. All of that research can happen in parallel, and then it can be compiled back up into something that then reasons about, found and cited source. So parallel is a favorite one of mine. And one of the biggest problems with complex agent architectures is inference speed gets to be a pain in the butt. We love using Grok with a Q. So it's like a super fast inference company, made in America, silicone kind of stuff, and they absolutely crush. But even then, when you get a ton of agents talking to each other, inference is like as you see ChatGPT peck out tokens, right? Or peck out characters. That's actually its reasoning, or that's how long it takes for it to move. And so if you have a bunch of those happening, it could take minutes for the LLM to respond. And in some cases, that's just it's not reasonable. The UX gets so bad.
Mm-hmm.
So by parallelizing research or something like that, you can end up with a much nicer user experience.
Sometimes when we talk about these patterns, they feel a little prescriptive. Like, this use case equals this. So it's always going to be a swarm. It's always going to be a supervisor. It's always going to be parallel execution.
Well, the definition of a pattern is a problem paired with a solution.
Yeah, but I think that we get a little prescriptive on those, even in traditional software. So all we do is say apply the pattern.
Yeah.
Right? And then what we don't think about is exactly the kind of questions we have about the use case.
Mm-hmm.
Right. And so I could think of a variety of patterns for something to automate, I don't know, right scaling a Kubernetes cluster. Right. And it really depends on when you're going to actually do the work.
Yeah. I mean, pattern is problem paired with solution and often applied so that people can reason about the solution more quickly. So if I can look at, say I'm using domain driven design, or I have think of a random pattern. I'm using a service repository pattern in a Java app. The reason I do that is then I know that in the service we're doing, certain things, in the repository we're doing certain things, and I can know where the code is and should be. The agent patterns are similar. Like if I have, 6 agents swarming, I want to understand what those agents are. If I single responsibility, I understand how they talk to each other. And similar with supervisor, I want to understand where decisions inside of my agent, graph, where decisions are made inside of my agent graph, so that I can, as a developer, go and change those, update those, change prompts, add behavior,
right,
all that kind of stuff.
Yeah. So the pattern has a utility function too for maintenance.
That's the whole point of a pattern.
Exactly.
Yeah.
Right. That's the key point.
Yeah.
Yeah. It's interesting though, sometimes we like to talk about how patterns will go away when agents become so powerful that they're doing their own.
Maybe, or new ones will come. Right now, and I talk about this a lot, and we can talk about it later, but almost all patterns are human. They're a human experience or a dev experience thing. So why do I have a class? Why do I name variables a certain way? Why do I use object-oriented design or functional design? It's so I can reason about complex systems more rapidly as a developer, change them and maintain them. And if I'm not maintaining them, but AI is, there will be new patterns that are good for AIs to manage those systems.
So I want to continue this thread with an article that Anthropic released. So they have a very good take, sort of a 101 on how to build effective agents. And one of the things they talk about is, again, this concept of patterns. And they talk about you might actually not even need an agent. So keep it simple, start from the scratch, use composable patterns. And then they talk about workflows. They talk about different types of workflows. So some of the stuff that you've talked about, in terms of having a linear sequence, having swarms, having kind of this conductor pattern, right, versus agents, which are truly, they differentiate between workflows and agents, with agents being something that that is model driven and is autonomous in terms of how they make decisions. And there's not, compared to workflow where it has a fixed number of steps, agents are open-ended.
Yeah.
Right. So I'd love to hear your take on a kind of what Anthropic has defined as workflows versus agents, and kind of the patterns that they called out here.
Yeah. One of the things that stood out to me is they say frameworks are UX step. right? And we keep saying LangGraph.
Right.
I generally disagree. One, Anthropic has a vested interest in you integrating directly with Anthropic APIs. So they're going to say don't use an abstraction layer because
Right.
then if you tightly couple to their APIs, hell yeah for them. But two, I think that there's like managing a framework and abstracting the framework allows you to pull through the life cycle and a long life cycle of that abstraction and get the speed. Wow. The way I said that was absolutely fucking confusing. If you abstract a framework, or if you think of a framework and you use it for what it's good at, and you put your business logic aside from that. So LangGraph is there to help you abstract the LLM calls and give you better eval and all that kind of stuff. But I'm going to put my business logic into raw code. I can avoid the tight coupling to the LangGraph framework. So if for some reason I needed to rip it out, I could.
Yep.
I can still iterate quickly, and I get all of the benefits of that abstraction throughout the life cycle of my software project, which can be years or decades, kind of thing. So I'm a big fan. Use those abstractions; they work really well. And I can't imagine building a web server from scratch. Like people, like we build apps on top of abstractions. Ruby on Rails is an abstraction. Spring Boot is an abstraction. Like these are all abstractions.
Compiled code is an abstraction.
Right. And so like these abstractions help us as developers move faster throughout.
Yeah. One thing that you just said resonated with me, and there's kind of a silly example that I can think of, but when I was building those poker agents, right, I don't want the agent to make up stuff about the state of the world.
Mm-hmm.
So the rules for the engine itself are just Python. Like it's just written in Python.
Yeah.
And I can rip that rules engine out. I could use it to do a fundamental like normal game. I can use the tool calls in the agent to have them reconcile state with reality and like not come up with malarkey on, I don't know, whose betting round it is or what the blinds are or things like that. So that's a real clear delineation between the two. The other thing I think that's interesting about LangGraph, and I want to call it out, is I think people don't understand that this is still open source.
Yep.
And so it is constantly being improved upon and iterated upon by the community because it is an open source project. You can contribute to it yourself. So I'm with Austin on this one. I think, Anthropic might have they might have a different horse in the race if they're like, oh, just integrate with our stuff. You'll be fine, right?
Mm-hmm.
You lose out on that community contribution.
So where do MCPs fit in this conversation? Because I think who came up with MCPs? I think it was Anthropic, right?
Anthropic did, yeah. MCP, I think I said it before, I'll say it again. My definition of where MCP fits is it is great for integrating with an agent you do not control. So I'm a user, I'm using Claude.
An API you don't control.
Yeah. Or an agent downstream that you don't control, right? So I'm using Claude. I need it to look up weather data. I need it to look at my calendar. I don't necessarily control that API, that integration. I need some way to communicate with it. I think that's an appropriate use case.
Yeah, I think at MCP, the first use case was for the Claude desktop app.
Right.
And you could then have Claude desktop interact with other stuff. And so how can I get my chat app to call tools was the definition of the spec. If I'm writing code, I don't need to have a way to get my chat app to, and I mean app, to call tools. I can actually write those tools and build those tools.
Yep.
MCP is a really nice protocol for sharing, but there's a ton of complexity and security issues that sit on top of the protocol right now, and they're getting fleshed out, but it's a very new protocol. And honestly, most of the time building just a tool SDK is a lot easier. The other thing they said in this article is that tool design is the new UX. I 100% believe that.
Yeah.
100% believe that we are now building to a new user, which is agents or agentic systems or whatever.
So do you think this whole conversation, these tools are not being talked about enough? Like we talk about what we hear in the industry are these flashy terms about agents, about, MCPs and all of these things. I feel like tools are a bit underrated. I don't know, that could be my perception, but I feel like tools are not being called out enough.
I mean, I think they're talked about, but they're kind of hidden behind the magic of the LLM.
Yeah.
It's once you build a tool, the LLM can use it.
Mm-hmm.
It's all of a sudden people, everybody's using ChatGPT, and all of a sudden ChatGPT can search the internet.
Mm-hmm.
And whoa, it's getting more real-time information, and it's doing it like every time I talk to it versus like having to click a button. Like that's good tool integration. And so we don't, I mean, in the dev community on X and on the internet and stuff, there's a bunch of conversations around how to build tools, but it's definitely not at the forefront of like, how does my, for a business leader who's non-technical, it's like they just wanted AI to, AI their workflow.
Mm-hmm. But would you say tools are the secret sauce?
Tools are the secret sauce. That's the hard part. And when we build agents for customers, and when we do like our AI readiness or anything like that, like what we're doing is we're looking at those integration points on where we can build those tools. And larger enterprises are coming to us and saying, how do I build tools to share across my enterprise? So I can have agents integrate in a singular way with existing systems. So that is the core of like most agent builds, the tools.
I think the dirty secret of tools is that this is the boring tech of agents and LLMs, because a lot of times the tooling looks a lot like traditional code.
It is traditional code.
That's what I'm saying. Like it's boring. It's not sexy. Right. And like it's not talked about a lot because you're going to have very similar code paths that you would in a typical software application. So they are fundamentally the way things work, but I hate to break it to you, it's just code.
Yeah.
But we just package it in a nicer
it's code that an LLM can call, but
it has a new user. Like it's yeah.
Next week, we're going big. We untangle what it means for agents and humans to collaborate together and shed some light on the new practice of agent experience. Remember to respect the craft. Evolution doesn't require chaos, and teams will always beat heroes.